Hey everybody, Mr. Bowman here. In this video we're looking at 3.14 probability distributions, and of particular we're focusing on all the achieved questions for the 2024 exam. All these questions I've kind of dumped onto a link which is in the description to this video if you want to check out more achieved questions. So we've got question number 28 is what we're looking at here. And the context of this one was a bit weird. So a person's belly button, for some reason they did a series of questions based on this, is described as an innie or an outie, blah blah blah. We've got a whole bunch of more description here. The numbers and the good stuff comes into here. Data on belly button types were collected in a belly button world first survey. From this data, 96% of people had an innie. Use the appropriate distribution to calculate an estimate of the probability in a class of 30 that no students would have an outie. So I guess the first thing to note is the question specifically talking about outies, so we need to find the probability of an outie, which would be 1 minus 0.96, which was the probability of an innie, which is 0.04. So that's the first bit of information we need to consider. The next bit is it's asked us to choose an appropriate distribution, and you got to think about which one is going to be relevant here. You have been asked to justify it, but I think in this case it's a clear example of a binomial distribution because you got two outcomes, right? You got an innie and an outie. You've also got 30 trials, so these are clear evidence of that. So let's write that down. So we're going to use a binomial distribution. And when you're using a distribution in the exam, you must write down what distribution you're using. If you don't, you genuinely will miss out on some really easy marks. And because we're trying to find the probability of exactly 0, specifically we're going to be using the binomial point mode, or BPD, on our calculator, right? So x equals 0 is what we're trying to find out. So from our context, we know that x equals to 0 because we're trying to find out 0 innies. N equals to 30, that's our trial numbers, that's each of the 30 students in the class, and the probability of a single student having an outie was 0.04, and when you plug all of that into your binomial distribution point mode on the calculator, you get 0.2939. So if you don't know how to use the calculator for this stuff here, let me know in the comments and I can reply with a video of me showing you how to use that. We are now on to question number 30, and we've got more belly button related stuff, but we've got some information about a fluff, and here is a distribution of the weight of that belly button fluff, and you can see in micrograms down the bottom there the weight of the fluff in each of these belly button things. This distribution has 502 pieces of information about this. I'm not sure how they got 502 people to participate in this, but here we are. It is proposed that this can be modeled by a triangular distribution, and yeah, that claim looks makes a bit of sense. That looks like a bit of a triangle there. Maybe this curve bit here is a bit weird. And we've got the parameters maximum, minimum, mode, and our job is on the diagram above just to sketch out what this triangular distribution would look like. So probably one of the easiest check marks you'll get. So first note is we're going to plot our 3 points onto our graph. So we have our maximum is going to be down there. Oh, so that's our minimum. Sorry, our maximum of 7.4 is all the way up here, and our mode, our highest point, was 1 milligram, and that's going to be about up there on the diagram. So once you got that, the question all simply required you just to connect those dots. I'm going to do it freehand, but hopefully in the exam you would have done it with a calculator. So going down like that, and then going across like that. So if you're able to sketch a diagram like that, hopefully your line there was better than mine. You'll be able to get your achieve mark. We're now on to question number 30, and this, again, another bit of a weird question. So we've got a random discrete variable, so they've confirmed that in the question, and the information here relates to the number of towels used per person for residents from a city over one specific day. So you got the table here, so that person there, they've used 0 towels, and the probability of that occurring was 0.129. These people over here, they use 3 towels, 6 towels over there. Hopefully you get the idea. The question is, how many on average were used over one day? So how many towels, or another way of saying this is, what's the mean number of towels people have used in the city over one day? So in our case, the mean will always be equal to t times the probability, and then we're going to add on the next t times its probability, and then we add on the next one plus its probability, and so on until we've completed all 6 probabilities. So let's get into that math. So we're going to have 0 times 0.129, that's the stuff sorted. Then we're going to add on 1 times 0.271, that's all sorted now. Then we're going to go plus 2 times 0.264, plus 3 times 0.185, plus, oh gosh, 4 times 0.095, and then we've got plus 5 times 0.039, then finally plus 6 times 0.017. So I've used all that information now, and this is trickier, so I'm going to plug all of this into my calculator, and when I do that, I'm going to get 2.031. Now this question here, looking at my answer, this question here, mean, a whole bunch of that numbery stuff, there's no meaning to my answer here, I don't think. So the previous question, there was a bit of meaning, but here, this, there's no context here. So I'm just going to add in a short sentence to add in context, because every question should have some link to context, or else you might miss out on your marks. So this means that on average, each resident used about 2 towels per day. There you go, and that just wraps it up. So finally, final achieved questions, only 4 in this exam, but we've got question number 31 to deal with now. And we've got here a 2012 study based on 138 people, so that information might be useful. I always circle totals. Blah, 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 blah. Information about their belly button habits. Again, another weird question. And in particular, this time around, they did a distribution on how many times in a 7-day week that a person washed their belly button. And a media release based on this study has said, shocking, less than 1/4 of US citizens washes their belly button daily. Comment on this if this headline is correct. Use numbers and statistical calculations with the reasoning to support your answer. So I guess the first thing to note is daily. So for me, if I can find the probability that X is 7 or more, so if you're washing your belly button once per day, you're going to be washing it at least 7 times, but maybe more than 7 times, because you might be having 2 showers a day and washing it twice, or whatever. So in terms of the graph, it looks like, just these kind of group here, these are the people washing their belly button daily. So on the graph here, so it looks like that there is 32, so I went across there and estimated. I am estimating, so there might be a little plus or minus issues type there, and it looks like there's one person there who washes it a few times a day, so it looks like 33 people here are washing their belly button daily. So that is just a regular kind of year 9, 33 over 138 type probability, and I put that into my calculator and I got 0.2468, and that number there, that is roughly a quarter, which is what relates to the claim. Specifically, the claim says less than a quarter, and you can see this number here actually is slightly less than a quarter, isn't it? So that kind of backs up this claim. So let's explain what this number means, and then after that we're going to link it back to the claim that they've made. So this number means, that the probability of someone washing their belly button or D there daily, i.e. 7 washes or more per week, is 0.2468. So that's just me explaining what my number means, and I've done that in a few of the questions in this video. Finally, we need to specifically link it back to the claim. 0.2468 is less than 1/4. So I agree with the claim made. There we go, full stop. So hopefully that wraps up all the achieved questions for that 2024 exam. If you've got any questions specifically about how the calculators are used, don't hesitate in asking me in the comments, and I'll reply with a resource that might help you out. Thanks again.